1, 2, 3, start.
Hello, Laoshi.
Hello, Hosan.
Yes, Laoshi. How are you?
Fine, thanks. And you?
I'm also fine.
You are in the dormitory?
Yes, Laoshi.
Okay. So we'll begin, as said by Jahi.
1, 2, 3, go.
Yeah.
Yes, Lashi, we need to start.
When do we start? Right now. In
Lashi,
the
I am
last,
in the shop.
you are in the shop.
Yes.
You are so free.
Not actually. Actually, it's for network.
Pardon?
Actually, for good network.
You don't have a good network, or you have a good network?
Yeah, I have now. I have good network, but when I stay in my home, that's not good actually.
Oh, you are in your country, and when you're at home,
Yeah.
the network is not good, so you go to the shop to have a good night to participate our class.
Yes, like this.
Wow. I'm going to cry because you are so interested in our class that you go to the shop to participate, to join us.
No, it's quite no problem.
Thank you very much. Oh,
Thank you.
yeah, it's good to see at least hear your voice. And in the last, yes, and that means the day before yesterday, we have talked about the scaling agile methods. We said there are two perspectives of the there are two perspectives on the scaling of agile methods. Do you remember now? Are you still excited? Two perspectives. Two perspectives. Yeah. Oh, thank you, Roy. Thank you. Yeah. For the scaling of agile methods, either we can scaling up perspectives to extend our agile methods to some larger software systems. And another one is the scaling out perspectives to introduce the idea of agile methods across a large organization, perhaps with many years of software development experience. However, it is still difficult to introduce agile methods into large companies for different reasons. Yeah, as large systems need upfront design and some documentation. Continuous integration is practically impossible when there are several separate development teams working on a project. So it's difficult to scale agile methods for large systems. And later, we have talked about the requirements engineering. We have said that, in
Hello,
one
Lashi.
classification, we can separate requirements into two kinds, the user requirements and the system requirements. Can you explain? Thank you, Roy. And can you explain these two kinds of requirements? Like the definition. Uh-oh, what I have done. It's not this one I want to do. It's here.
Do you wanna elaborate that user requirements and system requirements? That one?
Yeah, Shivli. Requirements.
Well, user requirements is something like a user wants, and system requirement, as you know, like to run that program or the software in a system. What is the system requirements like? how much RAM, how much space do we need? Something like that, isn't it?
Yeah, partly, but not. Yeah, not
Totally.
all. Yeah, not totally.
Okay.
Thank
Okay.
you very much, Shibli.
You're most welcome.
And other propositions? User requirements, user stories, demands. Yeah.
User story, user demands,
Mm,
user security, user design, development.
Hosan, you said it.
Yes, I am.
Yeah. Partly like this too, and in fact, user. Yeah. A big difference and system requirements, environment required to run the software. Yeah, Roy has got has gotten the majority of the things. In fact, the big difference between these two requirements is that they have different levels of description, as said by Hosan, Shibli, and Roy. User requirements. Usually, we describe what services the system is expected to provide to system users and the constraints under which it must operate. Usually, we describe user requirements in a natural language plus diagrams. And user requirements, usually we use them for, as we said, users. And system requirements are more detailed descriptions of the software system's functions, services, and operational constraints. With the system requirements, we define exactly what to implement. And system requirements may be served as a contract between the system buyer and the software developer. So system requirements are rather for system developers. You see the readers of these two requirements are different too. Yeah. And in the later of the last class, we have talked about another classification of software system requirements. We can separate system requirements into functional and non-functional requirements. Functional requirements are statements of services the system should provide, how the system should react to particular inputs, and how the system should behave in particular situations. Non-functional requirements are constraints on the services or functions offered by the system. Yeah, are very different. Yeah, a big difference between functional and non-functional requirements is that the functional requirements describe what the system should do, and if a system function doesn't really meet their needs, the needs of that means the needs of system users, we can usually find ways to work around the system. But if we fail to meet our non-functional requirements, that can mean that the whole system may be unusable. So we say that non-functional requirements are often more critical than individual functional requirements. These are differences between functional and non-functional requirements. Now, often functional requirements depend on non-functional requirements. No, not exactly, because the functional requirements not exactly it depend on that, because functional requirements may describe the services the service of the system, and non-functional requirements maybe some technical things depend on. As we and can we say it's a dependency relationship between these two? Not exactly, but yeah, partly some non-functional requirements can
Especially if you
decide.
can say that.
Pardon?
Say that it's dependent, like partly, as you say.
Yeah, partly. Yeah, I think it's partly. And yeah, with non-functional requirements, we may decide, yeah, some functional requirements, because with the implementation, we can get the exact services we will realize. Can you give like a real life example for this? Okay. For functional and non-functional examples, yeah, we may have a functional requirement, as we have said before, a functional requirement for for a system, maybe yeah, a medical system. We may say a medical system should be easy to use and be and should keep the privacy of patients. This is a function. We can consider it as a functional requirement. Easy to use and private and keep the privacy of patient's privacy. And then for the non-functional requirements, we say that the end users of the system can use the system after a training of 3 hours or 2 hours, something like this. And users of the system should authenticate themselves using their health authority identity card. Yeah, is it much more clear? Yeah, and for functional requirements, it's more general, I can say. And for non-functional requirements, it's about some technical things like system requirements, but not actually system requirements. Non-functional requirements are like items. What does it mean, items? I see. Accessories, extensions. Yeah, but very important extensions. Not some extensions that we can use, we can update or not. We can choose to update or not. But some essential extensions. The difference is that non-functional requirements describe how the system works, while functional requirements describe what the system should do. Yeah, it's correct too. As said by François, functional requirements describe what the system should do, and non-functional requirements describe how we work, how we do these, how we realize these functions. Yeah, François, the explanation by François is good too. It is very good. Thank you. Yeah. So now we'll continue with the next section, which is we were here. We have a space. We had some metrics to specify non-functional requirements, and in this class, we'll begin to talk about the software requirements document. The software requirements document is a official statement of what is required of the system developers. That means what the system developers should implement. Normally, it should include both a definition of user requirements and a specification of the system requirements. And sometimes the user and system requirements are integrated into a single description. Yeah, we may not separate these two kinds of requirements. In other cases, the user requirements are defined in the introduction to the system requirements specification. In some situations, such as if there are a large number of requirements, the detailed system requirements may be presented in a separate document. So this may include several documents. Here, we say that the requirement document is not a design document. It should set off what the system should do rather than how it should do it. It's like the functional and non-functional requirements, but the difference between functional and non-functional requirements are not so clear from. And normally, imagine the functional requirements is a service, and the non-functional requirements is something that we must satisfy to make the system working. If we don't satisfy our non-functional requirements, the system may corrupt directly. So it's quite different. It's not just what the system should do and how it should do it. Yeah, are you still there? Yes. So even this answer by Fazio, perhaps it's not correct, not totally like this. Yeah, it's not like this. It's different. Yeah, because functional requirements, it's the function, and a system may have different functions. For non-functional requirements, it's some technical things. If we don't meet the demands, then the system may not work. Yeah, it's the difference between functional and non-functional requirements, I think. As this one, ability to contain fluid without leaking, is to describe a service the system provides. And later we use some, because when we implement the system with this non-functional requirement, we may say, if the pressure is less than this value, then the system must not break. We may say halt the system or something like this. Yeah, then it will not work. These are non-functional, I think, or software engineering. There are so many notions, in fact, so many notions in software engineering, and there are not so much practices. So the distinguish between based on that what I said. But it's not. I don't think totally like this. What is done and how it should do. What should be done by the system and how it should do. No, not totally like this. I will okay. I will note this question, and then I will search for more information about it. We'll discuss it tomorrow, okay? With more details about non-functional and functional requirements. Yeah, because I don't think it's totally. Perhaps there are some ideas, but not exactly what you said. What should be done and how it should be done. Yeah. Okay. So now let's continue with this part. For we say the software requirements document should include both a definition of user requirements and a specification of the system requirements. And the document is not a design document. It should be a set of what the system should do rather than how it should do it. You see, even with this explanation, this one, here the software requirements include functional and non-functional requirements. So both of functional and non-functional requirements are what the system should do. It's not how it should do it. And normally, the requirement documents are essential, especially when we have an outside contractor who develops the software system. That means if we work with other companies or we ask someone else, some outsourcing companies, or in this way, in this situation, we need some requirements documentation, and it's very essential. However, many agile methods argue that producing a requirements document is a waste of time, as requirements change so quickly. The document is therefore always out of date. For agile methods, for example, when we use the extreme programming, we use incremental requirements engineering, and we express requirements as user stories, as we have shown in the last chapter. Then the user prioritizes requirements to implement in the next increment of the system. As we said, we collect the user stories and we divide them into tasks. We set the priority of different tasks and we develop the system. This is practical for business systems, but problematic for systems that require a lot of pre-delivery analysis or systems developed by several teams. That means if we use incremental requirements, if we ask a lot of pre-delivery analysis, or if we work with several teams, it will be a problem. And it's better to design the planning clearly and precisely before. Here, this figure shows possible users of the document and how we use the software requirements document. We see the possible users can be system customers, and they need to specify the requirements and read them to check that they meet their needs. Another type of users may be managers, to use the requirements document to plan a bid for the system and to plan the system development process. As in most of time, it's the manager who pay for the development of the system, who decide the price for the system. Another user may be system engineers. Not maybe. Normally, we should be. System engineers use the requirements to understand what the system is to be developed. And we have system test engineers to use the requirements to develop validation tests for the system. We have also the system maintenance engineers to use the requirements to understand the system and the relationships between its parts. As we have seen here, we have a diversity of possible users. It means that the requirements document has to be a compromise between communicating the requirements to different end users. And we should define the requirements in precise detail for both developers and testers. And we should also include information about possible system evolution. This information on anticipated changes can help system designers to avoid design decisions and help system maintenance engineers who have adapted the system to new requirements. The level of detail that we should include in our requirements document, it depends on type of system and the approach to development used. That means, yeah, we may have different levels of detail included in a requirement document, and these different levels depend on the type of system and the development process used. For example, critical systems need to have detailed requirements because safety and security have to be analyzed in detail. But for other types of system, perhaps it's not safety and security should be prioritized. Systems developed incrementally will typically have less detail in the requirements document, like the agile methods. And requirements documents standards have been designed. For example, we have IEEE standard requirements documents. These are mostly applicable to the requirements for large systems engineering projects. Here, we have shown a possible organization for a requirements document that is based on an IEEE standard for requirements documents. Here, this standard is a generic standard that can be adapted to specific uses. And this information helps the maintainers of the system and allows designers to include support for future system features. Let's look at it in detail. For requirements document, we may have the preface to define the expected readership of the document and to describe its version story. We should have an introduction to describe the need for the system. And we should briefly describe the system's functions and explain how it will work with other systems. Normally, we have a glossary to define the technical terms used in the document, user requirements definition to describe the services provided for the user, system architecture to present a high-level overview of the anticipated system architecture, system requirements specification to describe the functional and non-functional requirements in more detail, system models to include graphical system models to show the relationships between the system components and the system and its environment. The system evolution to describe the fundamental assumptions on which the system is based. The appendix to provide detailed specific information that is related to the application. Also, the index to the document may be included. As we see here, we have so many chapters in a requirements document. This kind of documents are likely to be very long, and they should include at least most, if not all of these chapters. So for long documents, it is particularly important to include a comprehensive table of contents and document index so that readers can find the information that we need more easily. Yeah. Now we'll see the specification of requirements. Requirement specification is the process of writing down the user and system requirements in a requirements document. Ideally, the user and the system requirements should be clear, unambiguous, easy to understand, complete, and consistent. In practice, it is difficult to achieve because stakeholders interpret the requirements in different ways, and there are often inherent conflicts and inconsistency in the requirements. The user requirements have to be understandable by end users and customers who do not have a technical background, because the user requirements for a system, we should include the functional and non-functional requirements. Normally, the user requirements, we need to describe functional and non-functional requirements. And we should specify the external behavior of the system. But keep in mind that user requirements must be understandable by non-technical members. So it's better to write user requirements in natural language with simple tables, forms, and intuitive diagrams. Another requirements, the system requirements, are expanded versions of the user requirements that are used by software engineers as the starting point for the system design. Here we have more detailed requirements, and we may include more technical information. They add detail and explain how the user requirements should be provided by the system. And as we have said before, system requirements may be used as a part of the contract for the implementation of the system and should therefore be a complete and detailed specification of the whole system. It's important to keep them as complete as possible. Yeah. Later we have some possible notations that could be used for writing system requirements. Yeah, we'll talk about this one later after the break. Now I'll get your attendance. Yeah, have a break of 10 minutes, please. We'll be back. And okay, thank you. And I have thought about the question, functional and the difference between functional and non-functional requirements. In fact, yeah, for functional requirements, it's about the service. It's about the services the system should offer, should provide. And for non-functional requirements, they are not directly related to the basic services. They are rather related to some system properties like the reliability or the response time of a system. Functional requirements, we may say that we need to reply to a situation quickly, but we don't need to precise the system property at the response time, etc., or the capacity of input-output devices, or the performance of the system. Is it clear? Is it much more clear like this? It's not rather what the system should do and how we do it, but it's two concepts different. For functional requirements, it's about the services. And for the non-functional requirements, it's about the system properties. Is it much clear? You see, a service of our system may be, as we said, we should search for the list, the list of, as said by Roy, the payment system. For functional requirements, it may be customers should be successful to pay without risk, or in private. Then for non-functional requirements, it's not to guarantee this service, is to say that we have a response time, or we have a security, a system security. We cannot, the information of the user should be kept like this. Is it much more clear? Thank you very much, Roy, for asking me this question, because at first, I thought it was a simple question, and I didn't pay too much attention to it. And when you asked me, I felt that, even in my mind, it's a little confused. So during the break, I have searched the information and I have checked and concluded. Okay, thank you. Thank you very much for the question and for having understood what I have said. Thank you. So now we'll continue with our software requirements document. Here, in this figure, we have figured out the structure of a requirements document. This figure shows the ways of writing our system requirements specification. Here are some notations and the descriptions of the notations. As we have said before, it's better to write our system requirements in natural language. That means it's better to use natural language, numbered sentences in natural language to describe the requirements. And we say, it's better to express one requirement in one sentence. And when we write our system requirements specification, if we can use structured natural language, it will be much clearer, because the requirements, if we write the requirements on a standard form or template, then each field provides information about an aspect of the requirement. And when we write a system requirements, we should design description language. We should use graphical notations. We should use mathematical specifications. We may use, because when we design description language, we may propose some language like programming language. And with graphical notations, we can use graphical models. As we have seen before, UML diagrams. We may also use mathematical specifications to reduce the ambiguity in our requirements document. We'll see some examples, some detailed examples of these notations. In principle, requirements should state what the system should do, and the design should describe how it does this. So you see, as we have said before, here requirements include functional and non-functional requirements. So both functional and non-functional requirements state what the system should do. For example, the system should guarantee the activity of payment. It is our functional requirements. For non-functional requirements, the system should reply to end users in how much time. It is our non-functional requirements. And the design of our system is quite different. The design should describe how it does this. So you see that we can see that the system requirements should simply describe the external behavior of the system and its operational constraints. And we don't need to consider how the system should be designed or implemented. However, at the level of detail required to completely specify a complex software system, it is practically impossible to exclude all design informations. That means in some situations, we may, especially for large systems, we may interleave the requirements and the design. I said here, in practice, requirements and design are inseparable. Here we have listed several reasons. The first one, a system architecture may be designed to structure the requirements. The system requirements are organized according to the different subsystems that make up the system. As we say, especially for large systems. In this way, the architectural definition is essential if we want to reuse software components when we implement the system. Also, the system may interoperate with other systems that generate design requirements. What's more, the use of a specific architecture to satisfy non-functional requirements may be a domain requirements. There's some question? Yeah.
Yeah, the other page. Yeah. So can you just explain that second point? The system may interoperate with other system, and that one. Okay, I can't see. Yeah.
Yeah, here.
Yeah, and that generate design requirements. Like, can you just elaborate a little bit this one?
Yeah, the system may interoperate with other systems that generate design requirements. Yeah.
Yes, that one.
Okay. Because in certain systems, we may have we may depend on some existing systems. For example, if we want to generate, if we want to develop a shopping system, with this shopping system, we need the function of the payment function. Yeah.
Yes.
So this system needs to interoperate with the payment system, and this payment system may generate design requirements.
Still not clear. Like you were saying, suppose in a shopping center, the payment system and the the tagging system, right? You're saying something like that.
Yeah, the payment.
Yeah, the payment in the sense like suppose we are scanning a barcode of a system, like of a product. So that is also the reading of the system and the payment system. You are saying this two are different systems, or okay, I didn't get it clearly.
Yeah. Okay. The payment system it exists already.
Yes.
And this payment system has this existed payment system may constrain or limit our new shopping system, the design of our new shopping system. And this design.
Understood.
Yeah.
Yes. That
And
means suppose we are having one existing system already, and we have developed another system. So these two systems should interoperate with each other.
Yeah, and also you see the existing system may ask some requirements of the design of new system.
Okay, now understood. Yeah, got it.
With
Thank
some
you,
interface. You're welcome. And I have seen a question of Roy here. That's what I said. What were talking about all words functional? Okay. Oh, the survive. I mean said.
Yeah.
But what you have typed the name of not or are or is functional, but yeah. Not what they said are functional. Like what said by Faso. He said there's one situation is what the system should do. Here, what the system should do is the definition of requirements. It includes all requirements. both functional and non-functional. What he has said later, how the system should be implemented, it's the design. Normally, it's the work of a design. And even we say, in some situations, design and the requirements may be together, may be interleaved. But the definition is like this. Is it clear?
Yes, ma'am.
Okay, thank you. So now we'll continue. As we have said before, that natural language, when we write requirements, it's better to write with natural language, and we can supplement the natural language sentences with diagrams and tables, because we want to make the requirements understandable by end users, even they don't have technical backgrounds. That's why we have accentuated several times for the use of natural language. Used for writing requirements. Natural language specification is used for writing requirements because it is expressive, intuitive, and universal. This means that the requirements can be understood by users and customers. As we have said, here we have some advantages of using natural language specification. However, when we use natural language specification, it is also potentially vague, ambiguous, and its meaning depends on the background of the reader. That means with the same specification, we may understand it differently. So to minimize the misunderstandings when we write natural language requirements, we can follow some simple guidelines. The first one is to invent a standard format and use it for all requirements. That means we can ensure that all requirement definitions adhere to this uniformat. When we standardize the format, we may less likely to make some omissions, and we can check the requirements more easily. The second way is to use language in a consistent way. Okay, here we have two small tips. We use shall for mandatory requirements, should for desirable requirements. In this way, we can distinguish between mandatory and desirable requirements. And we know mandatory requirements are requirements that the system must support. So usually we write with shall, and desirable requirements are not essential, and we may use the word should. Another guideline is to use text highlighting to identify key parts of the requirements. In this way, we can pick out key parts of the requirement more easily. And the fourth guideline is to avoid the use of computer jargon. We should not assume that every reader can understand technical software engineering language. For example, some words like architecture or module, these words may be understood differently for people from different backgrounds. So avoid the use of jargon, abbreviation, or acronym. Another tip guideline is to include an explanation or rationale of why a requirement is necessary. It is particularly useful when requirements are changed, as this explanation may help decide what changes would be undesirable. Yeah, here, this figure illustrates shows an example requirements for the insulin pump software system. And here we illustrate how the guidelines we have seen before can be used. You see here, the first requirements, the system shall measure the blood sugar and deliver insulin if required every 10 minutes. Changes in blood sugar are relatively slow, so more frequent measurement is unnecessary. Less frequent measurement could lead to unnecessarily high sugar levels. Here, in this requirement, firstly, we see here we use shall. So this requirement is mandatory. We should, the system must support this requirement. Also here, we see we have a rationale for this requirement. We have explained why this requirement is asked. The second requirement, the same thing. Yeah, we have used shall to explain a mandatory, a necessary requirement. Also the explanation of this requirement.
Ma'am,
Yeah.
are you just meaning the shall is about that program or other things you are meaning? Yes, this one, 3.2. The system shall measure that one. The shall is, this one is means what? This one is about the program you are meaning?
No, it is the requirement. That means here is a functional requirement because we ask this service to be implemented in the system.
Oh, okay.
It's a requirement of the system. It's not the design. It's not like how we implement this function, this device.
Yeah.
The main aim for a system, right?
Pardon?
This is the main aim in the like main in the sense like the most important aim of a system, or something like that, right?
Yeah, it's like what we want the system to do.
Yes, that is what I'm saying.
Yeah. Because this part is important when we develop a system for somebody else, because the requirements may serve as a contract between us developers and system buyers. They ask us to do something. We need to understand exactly what they want. And later, after developing, we need to use these requirements to validate what we have developed. Yeah, that's why we have taken a bit more time for this part. Now we'll see the structured specifications. Structured natural language is a way on an approach to write requirements where the freedom of the requirements writer is limited and requirements are written in a standard way. Here, with the structured specification, differently from the natural language, with this approach, we can maintain most of the expressiveness and understandability of natural language, but we can also ensure that some uniformity is imposed on the specifications. That means we write the requirements in a uniform way. As we have said, for the first guideline, we say we need to invent, the guideline here. We say it's better to invent a standard format and use it for all requirements. In this way, we can make less omissions. That means we may be less likely to forget something, and also we can check the requirements more easily. This works. That means the structured specification work well for some types of requirements. For example, requirements for embedded control system, but it's sometimes too rigid for writing business system requirements. Form-based specifications. Form-based specifications include the definitions of the function or entity. Here, this part shows the information we should include in specifying requirements when we use a standard form. That's why we call it form-based specifications. What will be included in the requirements? We should include a description of the function or entity being specified. To define the function or entity, we should describe the inputs and where the inputs come from. Also, we should describe the outputs and where the outputs go to. We should include information about the information needed for the computation and other entities used. We should describe the action to be taken. Also, we should include pre and post conditions if appropriate. If a functional approach is used, a pre-condition setting out what must be true before the function is called, and a post-condition specifying what is true after the function is called. We should also include the side effect, if there is, of the function. Here are the information that we should include when we use a standard form. This part is a structured specification of a requirement for an insulin pump. Here, this example shows a structured specification. We see, here we describe the function. The function specified is to compute insulin dose, safe sugar level, and we describe the function computes the dose of insulin to be delivered when the current measured sugar level is in the safe zone between 3 and 7 units. Then we describe the inputs, current sugar reading, the previous 2 readings, also where the inputs come from. We read the current sugar from sensor, other readings from memory. Then we describe the outputs, compose the dose in insulin to be delivered. Where the outputs go, they go to the main control loop. And then we describe the action to be taken. Here we have a detailed description of the action. Later, we have the requirements, the precondition, the post-condition, and the side effect. You see here, it's an example of a structured specification. Now we'll see tabular specification. What does it mean, tabular specification? Do you have some proper understanding of tabular specification? Oh, I'm sorry. We can see this system in dialysis system. Sorry. chief, in my side, I just think that everything is functional, and the other things which what happened naturally is not functional. It's not functional, but it's also functional by God. No. Good one. We can see this system in dialysis system. It should do that. It doesn't. If doesn't, then there is some problems. Yeah, for non-functional system, for non-functional requirements, we should satisfy them, because non-functional system, non-functional requirements are some properties of the system, some essential properties of the system, like the performance or response time of the system. But functional requirements are about the services we need to provide by the system. If you have no other questions, we'll talk about the tabular specification. And what do you think of a tabular specification? For you, with your personal experience or perspective, what does it mean, tabular specification? Organized specification? Okay. In fact, tabular specification is a supplementary of natural language. As we say, it's better to describe the requirements in natural language, but with text, it's usually it's not complete, or we cannot describe all with text. So we can use other tools like graphics or tables. That's the why we introduce or involve tabular specification here. It is used to supplement natural language, and it may be particularly useful when we have to define a number of possible alternative courses of action. Yeah, as we see, we can, for example, we can use tables or graphical models of the system to show how computations proceed, how the system state changes, and how users interact with the system, or how sequences of actions are performed. So in these situations, it's better to use tables to explain. And we can also describe the actions to be taken for each of these situations. For example, the insulin pump systems bases its computations on the rate of change of blood sugar level, and the tabular specification explains how to calculate the insulin requirement for different scenarios. As shown in this figure, it is a tabular description of how the rate of change of blood sugar, how we use this rate to calculate the amount of insulin to be delivered. And we see that the rate of change here depends on the current and the previous readings. So with our table or tabular specification, we can explain this idea more clearly. You see, in different situations or different conditions, we can have different actions, corresponding actions. When sugar level is falling down, that means the current reading is smaller or less than the previous reading. Then we don't need to deliver insulin. If the sugar level is stable, they keep the same, and we don't need neither. When the sugar level increases and rate of increase decrease, that means the current reading minus the last reading is smaller than the last reading minus the previous last reading, then we don't need to deliver the insulin neither. But if the sugar level increases and the rate of increase stable or increases, then we need to deliver the insulin, and the dose to deliver is also calculated by this equation, this function. This is the tabular specification, which is a supplement of natural language. When we develop some systems, this way is important. As we have some difficulties to classify functional and non-functional requirements. I will stop here for this class, and all right, have a good time. So I'll say bye
Have
to
a good day.
you. Bye, thank you. Same to you.